So going over this one, so I ended up giving like 11 minutes. And most people were either done or very, very close to done. So we're getting better at timing. Before I get into this question, and this is probably not fair to say to a room full of people who are in here today and choosing to be in here today. So I'm more saying this for the video. Well, I guess that's kind of pointless too. I'm kind of getting to the point where I'm getting really irritated. As of like 5 minutes before you walked in, I had 39 people who had even watched any of the notes from yesterday. I have 74 students. And the easiest question on the entire quiz from last Friday, I had people writing the wrong answer that had nothing to do with their quiz because they had heard somebody else say it. Which means they literally just didn't even look at their piece of paper because it's the easiest question on the entire quiz. And they just heard that somebody else said that was the right answer, apparently. It's not even on the version I gave this year. So I'm kind of getting irritated. So I might have to start treating people like children and like making sure you watch the notes and stuff like that, which I don't want to have to deal with, but I'm kind of at the point where I'm about ready to do that. Or at least give benefit to people who are doing what they're supposed to be doing. It's kind of the way I want to look at it. So stuff might change because of that, but we'll see how it is. I want to actually start with this problem with the two places that are going to get messed up the most. From walking around here in this room of the people who are in here today, most of you did very well with this. But overall, these are the two main places that on this problem I would expect to be counting off. And it's actually the same issue, it's just in two different places. So in normal, how do I check for normal? N times P naught. So it's not, there's no P. You have to do that greater than or equal to 10. And so these are not P hat, and these are also not just P, it is P naught specifically. Yeah.
When you write the null hypothesis, you write P naught.
Okay, so
you look for a P on
your null hypothesis is this.
Yeah.
And so this we plug in as a number. So you never actually see that it's there, but technically that's where it is.
So, but if you wrote P naught, where your null hypothesis?
Like here?
Yeah.
I don't want you to do that in the future because here you're saying P naught is a number and here you're saying it's like a parameter. And then so like, I don't think they would count off for that, but just so that you understand for like when I write stuff like this. So then the second place we see that, where's the other place in the whole four step that we use P naught specifically as opposed to P hat? The test statistics, so we're actually, so the square root part needs to also be a P naught, 1 minus P naught over in there. And while I'm at it, that's the top part of the equation. So like I said, when I was walking around, the people in here today did very well with this. I had a couple people doing the right thing, but just accidentally not writing the zero. Just make sure you make a note so that in the future you do write that. All right, so population here would be, I think I'm not right this. Population would be what? All boxes of this cereal brand of breakfast cereal. Then we define our parameter. So we say let P be the portion of boxes of this certain brand of breakfast cereal that included a voucher for a free video rental. Something to that extent. Then null hypothesis. P equals 0.2. And then alternative hypothesis is that P what? Because we're testing to see if there's evidence that it's less than 2. And remember, units do not need to be used for proportions, but when it's means, we should have written the units there. So moving down to plan. What's our first part of plan? Method, which is a one sample Z test for proportions. Do I need to have an arrow to Z here? No, because for proportions, it's always Z. So one sample Z test for proportions. And I am probably going to end up posting this answer key written out, so I'm not writing it out right now. This one, the random part of this one is kind of weird in the fact that it says that it's reasonable to assume that the 65 boxes, it's not like flat out we use a random sample. Do you really look at that problem any differently though?
It's said that the participant students.
And so it says, you're looking at it the same way, even though it's not just flat out saying it is a random sample, it's saying it's reasonable to assume that it was a random sample. You don't really look at that any different. I wrote it out a little bit more wordy in mine, but you can still say stated that it was supposed to be a random sample, and that's fine, which means random selection. Then we just talked about n times p naught. Okay, so finishing this out though, some people still mess up here because of what we did in chapter 8. In chapter 8, it would have given us a number of successes. So like this problem still gives us a number of successes as what? The 11. We do not use 11 here because that would be using n times p hat. And that is not what we want to do. So we actually do have to multiply 65 times 0.2 there. And that's, I should have finished that when I said that's where people mess up. So this one gives you what? 13. And then when we do the n times 1 minus p naught, that's 65 times 0.8. Well, you can do 65 minus 13. So again, and you get what? And then I would need to say there be at least 10 boxes of this brand of cereal that do and do not contain the free voucher for the video rental, then we can use one approximation. Independent 10% condition, we would say there are at least 650 boxes of this certain brand of breakfast cereal. So our do, our n is what? Our p hat. And so I would go more than that because it's going to change your answer. Because I usually go for, I'm going to go for, which means you're going to have to tell me what the value is because I think I rounded one more. My p naught is 0.2. What else do I need? Alpha is 0.05, and it is a one tail. So when I'm doing my test statistic, that just wrote out, so p hat minus p naught, everything under the square root is p naught. That whole thing is square root. And then, so plugging in my numbers there, 0.1692 minus 0.2. Well, that right there should tell me that my test statistic value is going to be what kind of number? Negative. So looking at stuff like that as you go is going to help catch mistakes because eventually or at some point you're going to type something wrong. And you get a test statistic value of about what? And then so draw it. Negatives over here. Which direction do I shade? Well, this is close to 0. At 0, it's 50%. So that's going to be kind of bigger than we usually deal with. We end up getting a p-value here of what? Compared to our alpha of 0.05. So what symbol goes in between? And then, for the most part, overall, y'all don't get a conclusion, for the most part. So, I'm going to my not direction because I put not right here. So, we Failed to reject, and you actually write out HO, P equals 0.2 since the p-value is not less than alpha, which means that we do not have convincing evidence that the proportion of boxes of this brand of breakfast cereal that include a free voucher for free video rental is less than 0.2. Yes. No. But like what you're asking earlier, like I do all positives or all negatives. That's the only reason I do this is because that starts that like all of my answers are going to be negative answers. Like I've taught it both ways, but that's the reason I do that. Any other questions just on this specific problem? Yeah.
For the conclude part at the end.
Yes.
Like in the problem, can we be like, because it says the group of students believe that the proportion of boxes with vouchers is less than 0.2.
Yes.
Can we just use that part
Yes.
in our conclude?
Yes, and that's absolutely fine. So, but then just being specific. So,
For like this
am I looking at the separated paragraph part?
the first paragraph.
This group of students.
It says, however, based on
Okay, okay.
experiences.
So you ended yours with. So we do not have evidence that.
The proportion of boxes with vouchers is less than 0.2.
Yes, that's fine. And using wording, like using exact wording from the problem is always fine. Like I said before, you could answer it like doing that in words or a word from the problem. And usually I'll just read one of them and not the other one, but yes, it's always fun. Any other questions on this specific problem?